Hello. Today I'll be talking about the triple scalar product and the volume of a parallelepiped. So this shape over here is a parallelepiped and we can use a triple scalar product to find the volume of this. The scalar product of vectors A, B and C is defined as A cross B multiplied dot product of C. And you can see here it's also equal to B cross C dot A equal to C cross A dot B. And when you find the scalar triple product, since you get a cross b as a vector and c is also a vector, you get a number, and the magnitude of that number, because it can also be negative, the magnitude of that number is equal to the volume of a parallelepiped. Now I'm going to prove it to you. First we find the area of a parallelogram, because if you see over here it's made up of many parallelograms. So if you can find the surface area of one parallelogram, we can use that to find the height. And once we know the height, we can use that to find the volume of the parallelepiped. So you have two vectors over here, a and b. It's divided by an angle theta. The area of a parallelogram is defined by the length a times the height, right? However, you see over here and that this height is at 90 degrees. This is a cross-sectional height. This is at 90 degrees to the surface. And so you see over here that this height over here is the vertical component of B. It is the vertical component of B, meaning that it's the sine component of modulus of B. Because if you do it, since this is a right angle triangle, sine of theta will be equal to h over the modulus of B. It is the opposite over the hypotenuse. So if you rearrange it, you get h is equal to modulus of B times sine of theta. And now you substitute mod of area times h, and now you substitute this h, and you get the result as modulus of a modulus of b sine theta. And looking at this equation over here, you see modulus of a modulus of b sine theta and cap. That's the cross product, and this is just the magnitude of the cross product, because modulus of a modulus of b sine theta is the magnitude component of the cross product, and this n cap over here is just the directionality component of it. So when you get mod a mod b sine theta, that's just the magnitude of the cross product. So what we have done here is we proved that for vectors a and b, the magnitude of the magnitude of the cross product is equal to the area of the parallelogram. Now we're going to find the volume. Now we know that the area of the parallelogram, you can see AB is over here. This is not a bit clear, but B is over here, and this is A. And this area, this is shaded area, this is one parallelogram, right? The volume is defined by the area times the height of the parallelogram. And so if you look at vector C, that's of the cross-sectional height is the horizontal component of vector C, right? So if you do this angle, which is phi, it's a little hard to see, but this angle here is phi. Cos of phi will give you h over mod C, because this is the hypotenuse and this is the base component. And rearranging this will give you h is equal to mod of C cos phi. Now the volume will be just the area times the height, which is modulus of the area is just modulus of a cross b, and the height is just mod c cos phi. And you see here, looking at this is very similar to the dot product formula, modulus of a modulus of b cos phi. So you can write this as a dot product of a cross b and c. So the volume is equal to modulus of that. It's because depending on what handedness you use, whether you use a right hand coordinate system, if you use a right hand coordinate system, your scalar triple product will always be positive. Otherwise you'll get a negative scalar product. However, since you're taking the magnitude of the volume, you're not taking this, you're not going to take this into account, because no matter what coordinate system you use, you should get the same answer otherwise. And if you modulus it, you'll get a positive value anyway for the volume. This is a worked example that I used using three vectors a, b, c. Vector a over here is 1, 2, 3. It's I plus 2j plus 3k. Vector b is 2 minus 4 and 7, which is 2i minus 4j plus 7k. And vector c over here is 0i plus j plus 3k. Now first you do is you find the cross product. Now if you're trying to find the volume of the parallelepiped, we have to find the triple scalar product. So first you find the cross product of A cross B, which is you'd use the ijk method, and you're able to find the component form, and you get 26 minus 1 minus 8, and then you cross product that with C, and you get the the scalar triple product as minus 25. And now you take the modulus of that, because the volume is always positive, and so you get the volume as 25 units cubed by the parallelepiped of these with these three vectors. And these are my references. Thank you.